And the next thing that we're going to look at, so the activities we've done up till now have all been about moving left, right, up, and down. The next thing we're going to look at is what do negatives do? How do negatives change the graph? So here we have y equals f of x in red, and you can color code this a little bit in your notes as well. If you do y equals negative f of x, and I've added a point on here, so I would like you to also label, if you had 8, 4 on the original graph, this blue graph, y equals negative f of x, and I'm going to put a box around it, that would be a reflection over the x-axis. And in the same way that I've been talking about inside and outside of the function, can you see that that negative is outside of the function? Outside of the function for translations move things up and down. Up and down is vertical. Now, with the negative outside, we still have something vertical, but this time it's a vertical reflection. It gets flipped over the x-axis. Similarly, if the negative is inside the function, and we can label a single point on here too, now the entire red graph gets flipped over the y-axis. Inside moves things left and right. Inside is horizontal. Can you see the graph has been flipped horizontally over the y-axis? So again, we're developing a pattern for inside the function, outside the function. Inside affects everything horizontally. Inside always affects the x values. Outside is always something vertically. Outside affects the y values. And then beside this, I'm going to get you to write the following. So we're going to start by writing y equals negative f of x. Sometimes the negative might be on the other side. And sorry if my writing is atrocious. If the negative is outside the function, and in brackets there I write with the y, because you could move the negative to where the y is. Then this is a vertical reflection. That vertical reflection is over the x-axis. It affects the y values, and the y values get multiplied by a negative 1. So notice from our red graph we had the point 8, 4. On the blue graph we had 8, negative 4. All that's happened is the y value got multiplied by a negative 1. So sometimes we want to visualize the whole graph, and sometimes we're going to want to be specific and just look at a single point. And then underneath that, we will look at describing y equals f of negative x. And here, if the negative is inside the function, that means that the negative is with the x. This is a horizontal reflection. Horizontal goes over the y-axis. And your x values get multiplied by a negative 1. So what we're getting in this description is a graphical representation of the reflection over the y-axis. We also get an algebraic representation by looking at the specifics that now our x values are getting multiplied by -1. Okay, everyone. Looks like everyone is done. Let's go to example 1. Here's the graph of y equals g of x. Sketch the image of the graph after reflection in the y-axis. So I'm going to reflect it in the y-axis. That is, just underline that. Okay. And above that I've underlined, I'm going to write a couple of things. I'm going to write horizontal reflection. That makes me think about the words, makes me think horizontally. Anything that happens horizontally happens with the x. So I'm also going to write the algebraic or the function notation. That would be a negative inside of the function. And I'm also going to write over the line x equals 0, because x equals 0 is another name for the y-axis. And the reason I wrote those 4 things is because this same question can be asked by changing the end of this with any one of those, right? You sketch the image graph after a horizontal reflection. Or I could say, sketch the image graph of y equals g of negative x. Or sketch the image graph after reflection over the line x equals 0. So we have the same question. I can change the words and ask it in 4 different ways. And that's something that happens a lot in math as well. They have all of these ideas that are connected, either a graphical way of saying it, an algebraic way of saying it. So you have to be able to interpret something and make those connections. Once we've made the connection that this is a horizontal reflection, so when I go to graph it, I like the idea of horizontal reflection. When I want to get to specifics, I might take this point and go, okay, that's going to get flipped over to here. What is happening is that my x-coordinate, which was -3,1, my x-coordinate is getting multiplied by a negative. So my x-coordinate is at 3,1. I'll just do that with the 1 point. For the rest of them, I take this point, reflect it over would be there. This point is 3 away from the y-axis, so reflected over would be 3 away on the other side. And this one's 5 away, so it'll be 5 away on the other side. And I connect my dots, and I have the reflection. Reread my question. It also says that it wants me to state the domain and range of each function, so I will color code it. My red one, the smallest value is -3, less than or equal to x, less than or equal to 5. And my range, my smallest y value is -2, less than or equal to y. My largest y value is +2. Do the same thing with my image graph. Now my smallest x value is -5, and my largest x value is 3. And my range still goes from -2 to 2. Does it make sense that the range didn't change? Right? Because we had algebraically the negative was with the x, it was inside, that changes the x values. Anything horizontally changes the x values, and your y values would stay the same. So we see that in our range. Our y values didn't change, but our x values did. Notice how the range changed? That everything got multiplied by a -1, so -3 became +3, and the 5 became -5. So I'd like you to circle 3 and 13.